What is the big takeaway about standard deviation? Well, you know what? Hell, let's make a double takeaway as we continue this discussion. Let's have a look back takeaway and a look forward takeaway, or a look current takeaway. We've got measures of center, which right now we are discussing x bar. And then we've got a measure of variation, which right now we are talking about little s. Somebody tell me how I should think about x bar. How should I think about that value x bar? Is that green? That's green. How should I think of if x bar is a sample average? Yes? Oh, yes. How should I think about x bar? What does x bar mean? What does x bar mean? If I had to put this into words, I mean, we know how to calculate it, right? We add everything up, divide by how many there are. If you had to put a meaning, a contextual meaning onto x bar, Aaron, what would you call it?
The number that we get if you evenly distribute it all.
Nice. It's the equal share. It's the equal share measurement. I like that very much. That's a very, very nice way of thinking about it. If you were to take all variation away and make all the data points the same, it would take the grand total of all the values and spread them equally. Good. I'm not saying that's always the best thing to do. I'm saying that's what the average is. And that's, actually, Aaron, you said that's what it is, and it's correct. So yeah, think of it as equal share. Anybody? That should be an R, not a D. That's an equal shade. Here. There we go. Anybody else want to say it differently? You can. Balance point. It's the balance point of the data. But I think that's getting at what Aaron says here. Good. Good. Once you've established what that is, what then is the sample standard deviation?
The square root of the sum of the x minus the x bar over n minus 1.
You forgot a square in there.
Yeah, the square stuff.
If you're going to be quoting math like that, Michaela, you better get it all right. But I don't want you to quote the math. I want you to quote what it means. That's right, Sarah, go!
Average distance from the mean.
It's the average distance of the data from x bar. So once you've established what x bar is, so the problem with x bar, as you just saw with Bert and Ernie, the problem with x bar is it eradicates all the variation. It treats all the data points as if they're the same. Well, that's not a good thing, because they're not all the same. There's a measure of difference between them. That's the best way to measure it. That's the best way to measure it. So the problem is, we spend all of our lives dealing with this. All of you could take an average when you walked into this room. I shouldn't say that. Most of you could take an average when you walked into this room. Hell, I made you do it on day 2. I put Inigo Montoya's soliloquy from The Princess Bride on the board, and I told you to guess the average number of letters per word. And everybody here gave me a number, which means you had at least a working knowledge of what an average was. If I asked you this on that day, you would have had full right to stick me in the neck with a pencil. Because there's nothing intuitive about that idea. Now there is. Now we have it now, right? But here's the problem. Here's the problem as I see it with understanding this. Put Bert and Ernie back up here. Oh, you can't see this. Here. The problem as I see it is, if you attach the idea of variation to center, Americans don't get it. They get center. Center, totally gettable. But as soon as you start talking about variation, they ignore variation as if it's not there. Well, here's a great example. Here's a few great examples, actually. There is a website called Headlines from a Mathematically Literate World. Okay, I think I may have shared this with you on 105. I don't remember if I did or not. If I didn't, I put the website up there. It's called mathwithbaddrawings.com. It's hilarious. This guy is extraordinarily intelligent, and he's extraordinarily bad artist. He draws on little whiteboards. He kind of draws like I do, terribly. But what he does is he pulls headlines out of the paper that are mathematically stupid and rewrites them mathematically correctly. And most of them that he pulls out of the paper that are mathematically stupid are because they're ignoring the idea of statistical variation. Check it out. Our world, local heat waves seen as a sign of global warming. How many of you have heard this before? I hear it quite often in the wintertime when it goes to 86 degrees. I'm out at Smith rocking a t-shirt. Yeah, global warming my ass. Okay, 90% of scientists agree that climate change is happening and the temperature is increasing. Why is it that a day of 86 degrees at Smith does not disprove or prove anything? Because the local heat wave not seen as a meaningful indicator of a trend. One day varied from average does not mean the average has varied. It just means Bert got 100 on the test. Does that mean his average is now 100? It just means there's variation that is being ignored, and we're cherry picking the one data point. You see what's happening there? We're ignoring that. We're ignoring that. How often have you heard average NFL salary? Average salary of a football player. Average football player salary, $1.2 million, something like that. No, the average football player salary is $0 because most football players never make it out of high school. What they've done is cherry-picked the guys in the NFL who represent a tiny, tiny, tiny little percent of football players. See what I'm getting at there, friends? You gotta look at the whole data set and the variation in the whole data set. Here's another one. Love this. Psychologists tout surprising new findings. This is, in my opinion, the worst disaster of inferential statistics. Is scientists are now trying to find something new all the time. Mathematically literate world, psychologists promise to replicate surprising new findings before touting them. Why? Why is this? Why do you have to replicate, Aaron? Tell me why you have to replicate. Why isn't one good enough?
Because of the chance for variation.
You're ignoring the idea of variation. The classic story of this, and we apparently haven't learned from it. There was a dude, I want to say 20 years ago, they were trying to prove he had ESP. Because they were doing the ESP exams on him, and the ESP exam, there's a deck of cards that has 5 symbols, 1 symbol per card. One's like a star. If you ever seen the movie Ghostbusters, the opening scene of Ghostbusters where Bill Murray's in the office with the cute co-ed and the poor kid who keeps getting shot. It's that deck of cards. So there's like a squiggles, and a star, and a circle, and a triangle. And the idea is, you try to read via ESP, extrasensory perception, what is on the back of a card that you can't see. Now, most people get about what percent of that test correct? 20%, because there are 5 cards, and if you can't see through the damn card, and if you don't have ESP, you're going to get roughly 1 in 5 correct by guessing. The same thing happened today during my touch therapy experiment. Flipping a coin, I was guessing 50%. I got exactly 50% with no variation. Very small sample, not hard to believe. What this one kid was doing, though, was he was getting consistently over the course of 3, 4, 5, 6 experiments, he was getting 60% correct. And they said, this kid, he's got ESP.
Was he just memorizing the cards?
No, he couldn't see anything. He was actually legitimately getting them right 60% of the time. And they said, he's got ESP. Wrote him up, published the article. Then they kept testing him. And what happened? He went back down to 20% because he was... It's the casino example from 105 all over again. The businessman in casino betting and getting ahead of Vegas. If you keep gambling, Vegas will eventually win and take all your money away. But at certain times, you're going to be ahead of the curve. They caught that kid ahead of the curve and wrote up an article about him that ignored the natural variation in his abilities. Once again, an average trumped without variation is an average that... Yeah, anyway. This is why replication is so important. Because it allows you to truly see the averages in the correct light. One of my favorites, this one shows up all the time, friends, all the time. Unemployment rate jumps from 7.6% to 7.8%. Well, 0.8 is more than 0.6. I don't know if I'd use the word jump. As a matter of fact, I wouldn't use any word because I wouldn't have written this. Because this is the actual correct statement. Why is that? Because what should those percentages have on them? We talked about this on the first couple days of class. Remember the little plus or minus at the bottom of the what are those called again? Margins of error. They should have margins of error. Guess what a margin of error is a measure of? Variation. It's how you measure variation across percentages. It's a different way of measuring variation. We tend to measure, in this class, we generally measure variation across measurements like test scores and things like that. But when you get down to probabilities, like 1/2 and 3/4 and things like that, then you start using what are called margins of error. It's actually more complicated than that. We'll get to it by the end of this course. But the thing is, what do you think the margin of error on this study is? What do you think? Maybe 0.2. Even if it was 0.2, I wouldn't believe it. Because if it was 0.2, this could be as high as 7.8, and that could be as low as 7.6. So in other words, the only margin of error that I would accept to believe this would have to be what? Actually 0.1. That would make me believe it. But if it was a margin of error of 0.1, they would have had to have sampled something like 25,000 people or something like that. I guarantee they did. They probably sampled 1,000 or 1,500. Which would mean the margin of error is around 3%. If the margin of error is 3%, can I actually believe these are different from each other? No! Which is why we can't really tell. Which means you'll never, in a mathematically literate world, you would never read half of those arguments that come up. You see what I'm getting at? When variation is ignored. And I blame Ted Turner. If you're here listening to this, Ted, I blame you. When he invented CNN, I think it's the worst thing that happened in news ever. 24-hour news! Is there really 24 hours worth of crap to talk about every day? No! That's why the news is filled with crap like this. They publish everything, even though 90% of it is meaningless. We gotta fill 24 hours. Let's go to sports. Why? Why? I don't get why we're going to sports. Although, did you hear about this? Kind of off topic a little bit. They showed an interview, Jon Stewart. I watched 5 minutes of Jon Stewart last night from April 10th. They interviewed the MVP from the UConn basketball team. Did anybody see this video clip? This kid was talking about how hungry he was most of the time. Turns out a large chunk of UConn, and maybe more teams in UConn, are living at essentially poverty levels, while the NCAA tournament pockets billions of dollars from advertising revenue. The kids that are in the games, a good-sized chunk, I haven't done the data on this yet, a good-sized chunk of them are actually, he mentioned being starving and hungry 3 or 4 times in one interview. And Stewart dug deeper, and Stewart has an agenda, of course. It's to make fun of all big corporations and things like that. God bless you, John. But the idea was that, I didn't even think about this, quite a few of those kids that come from these economically disadvantaged populations are hungry. They're performing at this ridiculously high level of athleticism in spite of the fact they're hungry most of the time. And John's question was the fact that the NCAA makes billions and billions of dollars off of these kids who are essentially starving, which I found extraordinarily disturbing, personally. I haven't dug the data yet to know how. That kid might be an outlier, yeah? But Stewart's point is he's not an outlier. He's fairly typical, which means his experience is fairly close to average, which makes me a little bit skeeved inside thinking about that.
That's why the good ones are all one and done. They come for 1 year and they take off and go to the pros.
Ah, to get out of that cycle. Oh, interesting. That's interesting. That's good support, anecdotal support. Yeah, anyway, I threw that out there because I saw it last night and it kind of like it bothered the hell out of me when I saw that. This kid kept talking about being hungry, and I thought Stewart was going to make fun of him for alluding to hunger with a hunger to win. But he wasn't. The kid was just literally hungry. Like, we go on the road very often. This tournament, they played how many games? I mean, how many rounds are there? He played 5, 6 games at high intensity levels. And then Stewart's point is you can't like write home for money because home doesn't have money. And the NCAA tournament isn't like catering to games. It's kind of disturbing. I'm sorry, I didn't mean to depress everybody a little bit. But the idea is that you got to account for both the variation, because I want to know whether that kid is typical or whether he's Bert's 61. You see what I'm getting at there? I want to know where he falls in this range. Variation gives us a measure for how to metric that. Because when you guys, the first thing you guys said today was, Ernie's more consistent than Bert. I love that statement. I love that statement. But how do you measure consistency? Well, guess what? Now you have a measure. Now you've got a beautiful measure. So let's take a big takeaway from today. Let's take away this and kick you out here a little bit early today. The standard deviation only makes sense when you put it with an average. Remember how she was the first one to define it for us. She said it's the average distance away from mean. The only way, it was constructed by comparing it to the average. So you have to make sure you pair it with the average. You have to know what the average is to have the standard deviation be meaningful. So that's why I like putting them together all the time. We'll put them together more on Tuesday again. This is what you guys just said multiple times. I'm going to have you, and I promised you I'm going to have you say it multiple times. I'm going to continue to have you say it multiple times. On average, it's how far the data points are from the mean. I'm intentionally being vague on this one. When S is big, It is highly varied or scattered. When S is small, it's not. It's highly consistent or clumped. Why do I put big and small in parentheses, or in quotes? I hate throwing words around that dimension. How big and how small? Would you say a standard deviation of 1 is big or small? This is a loaded question, FYI. Standard deviation of 1, big or small? Small? Who says big? Who says they can't tell? It depends on what you're measuring. That's the correct answer. If that is a measurement in inches, 1 inch, suppose it was 1 inch, big or small? Big or small? Small? Who says big? Who says it depends on what you're measuring? Suppose you're measuring bolt tolerance of a nut going into a bolt, which is, people's lives depend on this. Hundreds of people died in an industrial accident a few years ago when they put a suspension bridge inside of a hotel, a couple floors up, with bolts that were incorrectly measured as far as shear strength goes. Damn thing collapsed, killed a bunch of people. A 1 inch variation is inexcusable in that case because you're talking about hundreds of inches, if not thousands of inches. So the question is, make sure you know what you're measuring to know what big and small is. So that's why I put it in quotes. It depends on what you're measuring. The good news, we're going to know what we're measuring each time. So you'll be able to know, okay, 2 inches versus 1 inch versus 3 feet versus 5 miles, that kind of a thing. Have you ever heard things like, this military gun is so amazing it can hit the target the size of a dime from 15 miles away? Okay, that's impressive. That's impressive. Dime from 15 miles away, okay, I can live with that kind of variance. Right? I can live with a dime-size variance. I can't live with a dime-size variance when I'm measuring a bolt going into a nut. Does that make sense? So that's why I put it in quotes. And that's all we have time for today. I think that's a good place to stop. You guys look thoroughly exhausted. I apologize. That last little bit wore you out. I think the whole thing about the NCAA depressed you a little bit. Apologies about that too. Okay, we'll see you again on Tuesday. Right, I'll have boxes outside the office. I'm going to do that right now. That way you can drop stuff off if you need to. 226 upstairs.